All right, in example 2, we're given the graph of f of x, and we're asked to draw the graph of g of x and h of x, which are just transformations of f of x. All right, so g of x is defined to be f of x, and then we're taking the output of f of x and adding 2 to it. And then h of x is defined to be whatever the output of f of x is, and then we're subtracting 1 from that output. All right, so let's start with g of x. All right, all we're doing is taking the output of f of x and adding 2 to it. All right, so for example, you can see this point right here is on the graph of f of x. So when x is -1, f of x is 2. So if I take 2 and add 2 to it, I'm going to end up here, okay, at 4. All right, so the graph of g of x is going to contain the point -2, 4. All right, the same with there's a bunch of points here that actually cross or have an output of 2, right? And each of those is going to get shifted up here to 4. Okay, so I can just draw those in. Now, some other points that we can easily see, like this point down here, looks like it's 2, -1. So if I shift it up by 2, it becomes 2, +1. All right, so now, let's see, I'm going to erase some of these points that are not on the graph, because all I need to do now is connect those points. And so you can see now that this point got shifted up by 2. This point here is also going to get shifted up by 2. I don't know the exact coordinates of that point, but I know that the y value is going to be shifted up by 2. So I can just kind of approximate where that is. And the same here, it's gonna kind of go up here. So this point here gets shifted up by 2 as well. So let's try and connect those points. So let's see how well I can do here. So we're going to come down and then back up, and then we're going to come down. All right, and now let's see, we're going to come down here. Let's make that a little nicer. Down to here. Now this point, dips down a little bit below. Keeps going down a little bit more. So this one also gets shifted up by 2. I just don't know the exact coordinates, so I'm just going to approximate it there. And then I come back up. All right, so let's just connect that up. And you can see that would be my graph of g of x. All right, now I'm going to do a similar thing for h of x. So I'm going to take the output of f of x and shift it down by 1, right? Because h of x is defined to be f of x, and this with one subtracted from it. So I'm going to take the output of f of x and subtract 1. So let me use a different color for this, and let's come down here. So this gets shifted down by 1. This gets shifted down by 1. This point here. This point gets shifted down by 1. This gets shifted down by 1, and so on. Right? Every one of these points just gets shifted down by 1. All right. So here we get shifted down by 1. It goes like that. All right, so and this one also gets shifted down by 1, this point here. And now I can just connect those points. All right, so let's see here. I'm going to come down, back up, down. All right, let's see. It's kind of a challenge to draw this nicely. But I'm just going to come up. Okay, something like that. It's a little wiggly. But you get the idea. This is the graph of h of x. It's just the graph of f of x, but the output of f of x is just shifted down by 1. So 1 subtracted from it. Okay, so that's an example of those are 2 examples of vertical shifts, right? We're shifting the graph vertically. So let's kind of summarize what we just learned from those last 2 examples. If we take the output of f of x and add something to it, we're going to shift the graph up, right? So f of x plus a constant, k, is if k is positive, then f of x is shifted up by k units. Now, if we take the output of f of x and subtract a constant from it, a positive constant, then it's going to shift it down by k units. Okay? So that's just a summary of how vertical shifts work. And then we're going to talk about horizontal shifts next.